Hello students, welcome to Rhs classes. Today I'll be talking about some RMO geometry problems. Let's start with this question. In a triangle ABC, the incircle touches the sides BC, CA and AB at DE and F respectively. The radius of the circle is 4 units. The radius of the incircle is 4 units. And if BD, CE and AF are consecutive integers, we will have to find the lengths of the sides of the triangle. So basically we know that BD, CE and AF, BD, CE and AF are consecutive integers. Okay, and this is the incircle of the triangle ABC. This is our triangle ABC. This is the incircle we have, and we know that these are the radius because this is the incircle. So these lengths will be same. So starting with the question, we will take BD, CE and AF as n-1, n and n+1 because this is the easiest way we can represent 3 consecutive integers. So now we will join B and let's say this is O. So talking about this triangle BOF and triangle BOD, we have BO common to each other. So BO is common. Also OD equals to OF, since this is the radius of the incircle. And we know that since this is the radius and this is also the radius, so it will be touching AB at 90 degrees at the point F. Also this will be touching BC at 90 degrees at point D. So angle OFB is equals to angle ODB. So basically what we have is an Rhs congruency, which means right angle, hypotenuse and side. This is the right angle, this is the hypotenuse, and this is one side. So by this Rhs congruency we can say that BF is equals to BD congruent. Since this is congruent, so corresponding parts of congruent triangles, corresponding parts of congruent triangles. So by CPCT we have this BF equals to BD. Similarly we will have this is BF equals to BD. Similarly we will have CD equals to EF. Sorry, CD equals to EC. This is CD equals to EC, and we will have AE equals to AF. So we have CD equals to EC and AE equals to AF. So now coming to the question, we have BD, CE and AF consecutive integers. So we have taken BD as n minus 1. Since BD equals to n minus 1 and CD equals to CE, CE we have taken as, this is CE, right? We have been given the length of CE, so this will be CE. C equals to n, so CD equals to CE from here, and which is equals to n. This is CD, then it is equals to n, and BD is equals to n minus 1. BD equals to n minus 1, and we know that BC equals to BD plus CD. Here it is BD plus CD equals to BC, so BD is equals to n minus 1 and CD equals to n, so that will give us BC equals to 2n minus 1. This is part 1, and going to part 2 we have AB equals to F plus BF. So AB equals to AF plus BF, and we have found out that BF equals to BD, so BF equals to n minus 1 since BD equals to n minus 1, and AF equals to AE, and AF equals to AE, so AE equals to n plus 1 since AF also equals to n plus 1, so this is equals to n plus 1, and hence AB equals to AF plus FB now becomes AB equals to, the value of AF is n plus 1, as you can see here, AF equals to n plus 1, and BF equals to BD, and BD was equals to n minus 1, so this will be n plus 1 plus n minus 1, hence we have 2n, so AB equals to 2n, so we will call this part 2, and we have another part left which is equals to AC. Now AC is equals to AE plus EC, and we know AE equals to n plus 1 and CE equals to n, so AC equals to n plus 1 plus n, which is equals to 2n plus 1, so AC equals to 2n plus 1. So we will call this part 3. Okay, now there's a very important relation regarding incircle of a triangle, and that says that in radius of an incircle to a triangle R, we will call it, is equals to delta by S, and S is the semi-perimeter, which is equals to perimeter by 2, and delta is the area of the triangle. So in radius is equals to area of the triangle by the semi-perimeter. Now we know the lengths of the triangle, so the area of the triangle is equals to root over S into S minus A, S minus B into S minus C. People call it by Herons Theorem, or sometimes Herons Theorem. So that's basically, this is the area of the triangle, where ABC represents the lengths of the sides and S is the semi-perimeter. So going back to our previous slide, we see that BC equals to 2n minus 1, AC equals to 2n plus 1, and AB equals to 2n. BC, so BC plus AC plus AB whole by 2 will give us the semi-perimeter, which is equals to 2n minus 1 plus AC equals to 2n plus 1 plus 2n divided by 2. So this is basically equals to 3n. So AC is equals to 3n. Okay. Without loss of generality, we will take BC as side A, AC as side B, and AB as side C. So basically we have delta, which is the areal, equals to root over 3n, because S equals to 3n, and S minus A, S is 3n minus A, we have taken A as A is 2n minus 1, B is 2n plus 1, and C is 2n. So A is 2n minus 1, 2n minus 1, S minus B becomes 3n minus 2n plus 1, and S minus C becomes 3n minus 2n. So basically we have root over 3n into, this becomes n plus 1, this becomes n minus 1, and this becomes n. So what we have is delta equals to root over 3n square into n square minus 1. So our in radius r will be delta by s, which is equals to root over 3n square, n square minus 1 by 3n, and subsequently this is given as, let's go back to the question, this has been given as 4 units. The radius of the incircle is 4 units, so we have delta by s equals to this, which is equals to 4. Now from this we will try to solve the relation. So this will basically be 3n square, n square minus 1 equals to 12n square, 12 square. So this will be 3n square, n square minus 1 equals to 144 into n square, and ultimately this will come out as n square minus 1 equals to 48. So n square equals to 49, so n equals to plus minus 7. Now since n is the length of the side, and we took n as the length of side CE, since n is the length of side CE, so n cannot be negative, so n equals to plus 7 will be the only choice we have. Hence the sides will be 2n minus 1, 2n, and 2n plus 1, which was subsequently BC, AB and AC, BC, AB and AC. So this is BC, this is AB, and this is AC. So BC will be 2n minus 1, so 14 minus 1, which is equals to 13 centimeters. AB will be 14 centimeter and AC will be 15 centimeters. So the lengths of the sides are 13 centimeters, 14 centimeters and 15 centimeters, and this is our answer. Thank you.